Hello and welcome to The Explainer. Today we are talking about Apache Spark. You know all these big companies, Netflix, Spotify, ever wonder how they handle just massive amounts of data? Well, Spark is the magic engine behind it all, and we're going to pop the hood and see exactly how it ticks. All right, so here's our plan for today. We'll start with the why to huge data challenge. Then we'll meet the boss, the driver, and its team of workers, the executors. We'll look at how they talk to each other, and then we'll put it all together to see how a job gets done.
Okay, let's get right into it. To really get what Spark is all about, you first have to understand the problem it was designed to solve. So what was this big challenge that needed something like Spark?
So here's the fundamental question, really. What do you do when your data is just too big? I mean, so big, it won't even fit on one computer. It's like trying to drink the entire ocean in one gulp. It's just not possible for one machine. It'll just give up.
And this is where Spark's genius really comes in. It's a simple but powerful idea. Instead of trying to build one massive, super expensive computer, Spark says, hey, why don't we just get a whole team of regular computers to work together? So it takes that huge chunk of data, slices it up into smaller pieces, and hands one piece to each machine. Teamwork, right? But you know, a team with no leader is just chaos. You need a manager, someone who sees the whole picture and tells everyone what to do. And in the world of Spark, that manager is called the driver. This is the brain of the whole operation.
So think of the driver as the project manager, okay? It's the heart of your Spark application. It looks at the job you want to do, and it comes up with the most efficient plan possible. It doesn't actually do any of the hard labor, but it creates the perfect blueprint for the workers to follow.
And who are these workers? Well, they're called executors. Simple as that. They are the ones on the ground running on all those different machines in the cluster. The driver gives them a task, and they just execute it. They are the hands of the application.
And this table here, it shows that separation perfectly. On one side, you've got the driver, who manages and schedules everything. It creates the master plan, what we call the DAG. It's truly the heart of the application. And on the other side, the executors. They are the hands. They execute the tasks on the actual data and report back. It's a beautiful, efficient system.
So I mentioned this thing called a DAG. What is that? It stands for Directed Acyclic Graph. Now, that sounds complicated, I know, but don't get hung up on the name. Just think of it as the driver's master plan. It's a super efficient to-do list that lays out every single step of the job, making sure nothing is done out of order and no time is wasted.
All right, so the driver has made the plan. Now it's time to see where the real work happens. Let's take a closer look at the workers, the executors.
So here's where the real power of Spark comes from. See, each executor is a process running on a machine, and inside that executor you have multiple cores. Think of it like a chef with many hands. Each core can handle one task at a time, all in parallel. So one task gets one slice of data, you multiply that by all the cores on all the machines in your cluster, and suddenly you're doing hundreds, maybe thousands of things at once. That's how we get that incredible speed.
And this is the most important thing to remember here. It's a one-to-one relationship. One task runs on one core, and that one task works on one partition of your data. That's it. This simple, beautiful rule is the absolute foundation of how Spark works at scale.
Okay, so we have all these tasks running in parallel, but it's not always that simple. You see, not all tasks are created equal. Some are easy and fast, while others, well, they can cause a massive traffic jam across the entire cluster. And this is the key difference between what we call narrow and wide transformations. A narrow transformation is clean. Each piece of data stays on its machine. Think of it like a production line. Data comes in one end, gets processed, and goes out the other. Super efficient. A wide transformation, though, that's different. It's when data from one machine needs to be combined with data on all the other machines. This creates something called a shuffle, where data has to be sent all across the network. It's like trying to sort a deck of cards that's been thrown all over the room. It's messy, it's slow, and it's the biggest performance killer in Spark. Okay, we've met the driver, the executors, we know about data partitions, and we've seen the difference between narrow and wide operations. Now, let's put it all together and watch a Spark job from the very beginning to the very end. So it all starts with you, the user. You submit your job. Step 1. The driver immediately jumps into action, analyzes your code, and creates that master plan, the DAG. Step 2. Then the driver acts like a dispatcher, breaking that plan into small tasks and sending them out to the executors. Step 3.
The executors get their orders and start crunching the numbers on their assigned data partitions all at the same time. Step 4. Finally, as they finish, they report their status back to the driver, and the final result gets written out. It's a beautiful, coordinated process.
And check this out. This is a really cool detail. The process stays parallel all the way to the end. Since each task worked on its own little piece of data, the output isn't one big file. Instead, you get a whole bunch of smaller files, one for each partition. It's a perfect reflection of the distributed way the work was done.
So, let's just quickly recap what we've learned. The magic of Spark really comes down to these 4 things. First, parallelism, breaking up a huge job into tiny pieces and doing them all at once. Second, management. You have the smart driver making the plans and the hardworking executors carrying them out. Third, data flow, understanding the difference between those easy, narrow operations and the expensive, wide shuffles. And finally, all of this adds up to one thing: incredible scalability. It's an architecture built to grow and handle almost any amount of data you can throw at it.
And that's Apache Spark in a nutshell. But it does leave you wondering, doesn't it? The amount of data we're generating is just exploding. It's unbelievable. Spark is the go-to tool right now, for sure. But what's next? What comes after Spark, when the big data of today seems tiny tomorrow? That is the really big question for the future.